7.4, solving polynomial equations in factored form. All right, so we have to understand what factored form means, or what factoring means. So factoring a polynomial is writing it as a product of factors. So in other words, breaking it apart into things that you're multiplying together. So if you look at this, this is factored here. You could multiply those two binomials together and get x squared minus 4x minus 21. But that wouldn't be factored. This is broken apart into a multiplication problem where you get the smallest possible parts you can. Okay, so the solutions to a polynomial equation are also called roots. Okay, so we've got something called the zero product property. So this means if you have two things multiplied together and the product is 0, so the answer is 0 when you multiply them together, that means either the A has to be 0 or the B has to be 0, okay? So if you think about it, let's say the A was 7, well then B would have to be 0. Or if B was 13, then A would have to be 0. One of these two things has to be 0. Either A has to equal 0 or B has to equal 0, okay? So that we can use that zero product property if we've got something factored that equals 0. I have, hey, this times this equals 0. That means one of these two pieces has to equal 0. So that allows me to say, okay, well then either x plus 3 equals 0 or x minus 7 equals 0. And now I can solve both of these equations. So I would just subtract 3 from both sides here. So then x would equal negative 3. Okay. On this one, I would add 7 to both sides to isolate the x, and then x would equal 7. So if you try plugging these two values in, well, if you plug in a negative 3, that first factor will be 0, and 0 times this is going to equal 0. If you plug in a 7, it'll make that second factor equal 0, which would give you 0 when you do the multiplication again. Okay. All right, so let's try another here. We got two things multiplied together that equal 0, so that means either 2x plus 6 equals 0 or 3x minus 15 equals 0. We've got a little bit more work to solve these, but I'm trying to isolate the x, right? So I'm going to start here by subtracting 6. So 2x equals negative 6, and then I'll divide by 2, and x equals negative 3. Okay, now that's one solution, but I got to get both of them, so I got to solve the other equation over here. So here I'll add 15 to both sides first. 3x equals 15, and then divide by 3, and x equals 5. Okay. All right, and here we had two factors, but you could have more than two factors. Here we've got 3 different factors, okay? So that means any one of these could equal 0, and then when you do the multiplication, it'll all equal 0. So you can still use the zero product property here, okay? So either x minus 3 equals 0, or x plus 4 equals 0, or 2x minus 10 equals 0, okay? So here I'm adding 3 to both sides. X equals 3 for that piece, and then just subtract 4 here, and x would equal negative 4. On this last piece, oops, I forgot the 0 there. The last piece, I'm going to add 10 to both sides, so 2x equals 10, and then divide by 2, and x equals 5. Okay, so since there were 3 different factors here, I wound up with 3 different possible solutions. Okay, all right. This one, it might seem like, wait a second, there's only one factor here. But remember, this is x minus 7 times itself, right? So you could write this as x minus 7 times x minus 7 equals 0. And I can still use the zero product property. One of these two things has to equal 0. Now, it turns out they're both the same. So they're going to lead us to the same place. So both of these, when I add 7 to both sides, I get the same result. So you don't have to write the solution twice at this point. Maybe sometime down the road that might become significant. But for now, you can just say x equals 7. That's the only x value that will satisfy that equation. Okay. All right. Let's talk about the GCF, or greatest common factor. So this is going to be the largest monomial that goes into each term of a polynomial, okay? So I'm going to factor this. This is not factored. It's not broken apart into multiplication, but that's what I'm going to do here. I'm going to factor out the GCF. So that means what I'm doing with these two terms, I'm trying to think of something that goes into both of these. So first thing I'm noticing, hey, they're both even numbers. So 2 goes into both of them, okay? But that's not the biggest thing that goes into them. So just thinking about the numbers, 4 would go into 8 and into 24. Well, what about 8? 8 goes into itself. 8 also goes into 24. So 8's the biggest number that goes into both of those. But also they both have an x, okay? So I can factor an x out. So I'm going to factor out an 8 and an x. And the way I like to think about this is distributing. This is my greatest common factor here is 8x. So then I'm thinking, well, what would I have to multiply 8x by to get the original binomial? I'd have to do 8x times something to get 8x to the 4th. Well, I'd have to do 8x times x to the 3rd to get all the x's I need there, right? And then 8x times something would equal negative 24x. That would be negative 3. Okay, and you can try distributing the 8x back in. It will lead you back to where you started. Okay, so then this is factored. Okay, so if you just factored out the 8, I see that a lot, then it's not completely factored, right? So let's say you did that. Let's say you factored out the 8 and you got x to the 4th minus 3x. Okay, now that's not incorrect, but it's not finished yet because there's still a common factor. So then you could factor out the x. So you still have the 8 out there. Then you'd factor out the x, and you get x to the 3rd minus 3 in there, which is the same result, right? So if when you do your factoring, just check the parentheses to see, is there anything else that I can take out? And in this case, I noticed, hey, there's still an x that I can take out, okay? So let's try this with 3 terms. So I'm first looking at the numbers 7, 21, and 28. Well, I know 7 goes into itself and 21. 7 times 3 is 21. 7 times 4 is 28. So 7 goes into all of these. Then I'm checking the variables. Do they all have the same variable? Yeah, they all have an x. They all have at least one x. So that means the biggest thing that I can factor out here is 7x. Okay? And since the original was a trinomial, I'm thinking 7x times something is 7x third. You can also divide, like take 7x to the 3rd, divide by 7x and see what's left. But I kind of think of it as multiplication. 7x times something is 7x to the 3rd. That would be x squared to get all the x's, right? 7x times something is negative 21x squared, so that would have to be negative 3x. Okay, 7x times something is 28x. That would be 4. Okay, and now I factored out the greatest common factor. Sometimes you can factor the trinomials further, even after you've factored out the greatest common factor, but we'll get to that later on. For now, we're just factoring out the greatest common factor. All right, on the next page, let's look at solving equations by factoring. Okay, so here's the idea. We want to first set the equation equal to 0. So these first 2 problems, they're already equal to 0, but if you look down at the next 2, they're not equal to 0. Okay, so we want to get them equal to 0 first. Then we want to factor whatever's on the left side. So then I'm looking for a greatest common factor between these 2 terms, thinking what goes into both of those. Well, they both have an x. I can factor out an x. Okay, and then I'm thinking about distributing here. X times something is x squared. And then x times something is 5x. That would be 5, and I want to separate that like that, right? So if you distributed, that would get you back to the starting one. Okay, now I've got this written as a product of 2 factors, and that means I can use the 0 product property. I got 2 things multiplied together that equals 0. So that means either this equals 0 or this equals 0. When one of the factors is just x, I see a lot of people just leave this answer out, but that is a perfectly good answer. If you plugged 0 into the original equation for x, it would balance out, right? Because you'd get 0 equals 0. But you can also take the x plus 5 part, and when that's equal to 0, solve it for x, and x can also equal negative 5. So just a little spot check. I'd get 25 minus 25 equals 0. That would work out as well if I plug in the negative 5. Okay? All right, let's try another here. So hey, 3 and 9, well 3 goes into both of those, but then also they both have a y. I shouldn't have put the equal sign there because this is already an equation, okay? And then I'm thinking of distributing. 3y times something is 3y squared, and 3y times something is negative 9y. That would be negative 3. Okay, so now I've got two factors. And when you multiply them together, they equal 0. So zero product property tells me either 3y equals 0 or y minus 3 equals 0. Okay, this first one's a little weird, but you can actually use the zero product property again. But I'm going to just divide by 3. So y is going to equal 0, right? 3 times 0 would equal 0, so that makes sense there. And on the other side, I just add 3 to both sides. And then y is going to equal 3. Okay? All right. Let's try again. So this one isn't equal to 0, so first thing I want to do is set one of the sides equal to 0. It doesn't really matter which side, but I'm going to subtract 2x from both sides here so that the right side equals 0. Okay? The left side, those aren't like terms, so I'm going to have to just write it as 4x squared minus 2x. But now it's more like the previous problems, right? So now what I want to do is factor the left side of this. So I'm looking for greatest common factor. Well, 2 goes into both of those, and so does x. So I'm going to factor out 2x. Okay, 2x times 2x would be 4x squared, and 2x times negative 1 would be negative 2x. Now I've got these factors. So zero product property, either 2x equals 0 or 2x minus 1 equals 0. Okay? On this one, I'm dividing by 2, and x equals 0. On the other side, let's add 1 to both sides. I've got to write pretty small here. So 2x equals 1, and then we're going to divide by 2, and x is going to equal 1/2. Okay. All right, let's try one more here. So let's set this equal to 0. So I'm going to subtract 30 from both sides first. So 6x squared minus 30 equals 0. And now I'm going to look for a common factor. So hey, 6 goes into 6 and 30. So I can factor out a 6. And if that 6 times something is 6x squared, 6 times something is negative 30, that would be negative 5. Okay, and then zero product property, so this one's a strange one, because I've got these two factors. So 6 equals 0, well that doesn't make sense, right? 6 does not equal 0, so that doesn't lead me to a solution for x. But I still have x squared minus 5 equals 0, okay? And if I'm trying to solve this, what I'd want to do is isolate the x. So let's add 5 to both sides. So x squared is going to equal 5. All right. And then we're going to take this, well, let's do this as, we can think of this using zero product property again. You could take the square root of both sides, and that would be fine. But you can also think x times x equals 5, right? Just to continue with the zero product property. So if x times x is 5, either this equals, oh, it's not equal to 0. Sorry, I got distracted there. I can't use zero product property because it's not equal to 0. Okay, so what I'm going to have to do then is take the square root of both sides of this. And this is getting a little ahead of ourselves, but when you take the square root of both sides, we're going to get this, but there's a positive root and a negative root. So when you take the square root of both sides of an equation, technically you have plus or minus 5. There's a positive root and a negative one. So you could leave it like this, or you could put it into a calculator and figure out what the decimal approximation of the square root of 5 is. So that would be about 2.24, let's say. So I'm going to put approximately equal to positive or negative 2.24. Okay. All right. Last one. We got a word problem here. Okay, it says you can model the entrance to a mine shaft. So there's like a cave, right? The opening to a cave, a mine shaft, using this equation where x and y are measured in feet. The x-axis represents the ground. So this is the ground right here, okay? Find the width of the entrance at the ground level. So this is what we're looking for, the length of this segment between, here, let me highlight it. We're looking for the length of this highlighted segment, okay? So what we need to do here is to figure out the coordinates of those 2 points on the xy axis. Now, since this is on the x-axis, I'm going some amount right, 0 units up. So I already know that the y-coordinate is 0. Same thing here. I'm going left some amount and then 0 up. So I know that the y's there are 0. So now what I can do to find the x's, I can take this equation and I can plug in 0 for y and see what I get when for x when y equals 0. Okay? So I'm going to take this equation. I'm plugging 0 in for y. And I'm going to attempt to solve for x now to see what x's go with a y of 0. Okay, now this is already factored, so that's nice. So I've got these 3 factors and it's already set equal to 0. So I can use the 0 product property. One of these 3 things has to equal 0. Well, negative 1/2, that doesn't really make sense, right? Negative 1/2 doesn't equal 0, so just ignore that part. But then I've got x plus 4 equals 0 and x minus 4 equals 0. And I want to solve both of these. Okay, so here I would subtract 4 from both sides and x equals negative 4. Here I'd add 4 to both sides and x would equal 4. So those are what x equals, okay? So then if we go back to the picture, that means I went 4 left and 0 up. Here I went 4 right and 0 up. So those are my x-intercepts of that parabola, okay? And now I can figure out, hey, if this is 4 units here, and this is, I'm going 4 units to the left here, I'm just saying the length of both of those. So now I know it's going to be a distance of 8 between those two, right? Because I'm going from negative 4 to positive 4 on the x-axis. So the width at ground level is going to be 8 feet because it said the units are in feet. Okay, and that's the end of the section, and I'll see you next time.